Now normally you would associate exponents of x with log or ln, and that is definitely what we're going to be doing today. So the problem with this equation is that we have x's as bases, so that's fine, but we have an exponent of 1 and an exponent of x. So how can we get x to be a base? Well, we know a property of ln that says that ln of x to the power k is the same as k times ln of x. So we can go through the proof of this, but this is not what that video, what this video is about. So we're just gonna move on. So we're gonna introduce ln both sides. So mathematically, we would be correct to say ln of x to the power x is equals to ln x, introducing x on both sides. Now, this exponent is gonna come in to be a base. So we're gonna have x times ln x, this is equals to ln x. Now, we're just gonna be dividing by ln x both sides. Ln x is gonna cancel with ln x, then x is gonna be equals to 1. So that's very easy there. Now, when we move on to other equations of the same nature, we get some very interesting things. X to the power x, to the power x, to the power x, all up until infinity. And then we equate this equation to, let's say, 2. So you could pause the video and try this on your own. So let's look at the answer. Now, we can see that we have exponents that go up until infinity. So we would want these, essentially we would want these exponents to become a base. So what do? We introduce ln to the power x until infinity. This is equals to ln 2. Now, this is going to mean that this entire thing is going to come to the front, right? So let's do that. We have x to the power x all up until infinity, multiplied by ln x. This is equals to ln 2. Now, what do we have here? We have x to the power x up until infinity times ln x is equals to ln 2. But essentially, we know that x to the power infinity is the same as 2 from our original equation, right? So the fact that we took out the base x does not change anything, because these x's go up until infinity, so they're an infinite number of x's. So this is still 2, right? So I can put 2 here and I would not be mathematically incorrect. Then this is equals to ln 2, then we divide by 2, then 2 cancels out with 2, then I have ln x is equals to, allow me to write this 2 as 1 over 2 ln 2. Then we can say that ln x is equal to, now remember a property of ln, the base can come to be an exponent and vice versa. So I have ln 2 to the power 1 over 2, then I have ln x, I'm sorry for the camera, ln x is equals to ln square root of 2. So then I can solve for x by just making e the basis for each. E cancels out with ln, therefore I have x is equals to e to the power of ln square root 2. Ln cancels with ln, therefore x is equal to the square root of 2. So we can try to find out if this is correct by computing the square root of 2 into x into this infinite exponential equation by saying that since x to the power infinity is equals to 2, and we know that x is equals to the square root of 2, if you could compute a reasonable amount of square roots of 2 to the power square root of 2 in your calculator, this should give you a number that is very close to 2. It cannot surpass 2, but it will keep getting closer to 2. But it won't be 2 exactly, because you can't compute an infinite number of things. There's no end to infinity, right? So yeah, that's how we do that there. Stay tuned for more videos. Don't forget to like, comment, and subscribe. And yeah.